Hello and welcome to helpyourmath.com. In this video, we're going to look at solving higher degree polynomial equations by applying the quadratic formula. And just to review the quadratic formula, this works for quadratics that are of the form ax squared plus bx plus c is equal to 0. And we can figure out the two roots by saying x is equal to the inverse of b plus or minus the square root of b squared minus 4ac all divided by 2a. So we want to know our quadratic formula. There are bajillions of songs on YouTube if you want to see some other people performing songs to help you remember it, but you do want to know the quadratic formula. Okay, let's get started. For our first example, we want to solve the equation, and we want to write the answer in exact simplified form. So we have x cubed minus 64 is equal to 0. This is a cubic function, and this can have three solutions. I know it can have three solutions or three zeros because we have a cube. So the number of solutions we're expecting should match the degree of the polynomial. Now, it can have at most three, but it could have double roots. And when I say three, I mean complex. So we could have 0, 1, or 2, or 3 real solutions, but we always have three complex solutions. Okay, so what are we going to do with x cubed minus 64? We cannot apply the quadratic formula because this is not a quadratic, this is a cubic. One thing I notice about x cubed minus 64 is that it does kind of ring a bell. It's a perfect cube binomial. So perfect cube binomials, if we have x cubed minus y cubed, this will factor into root minus root times root squared plus the product of the two roots plus that second root squared. So we're going to first factor that and see where that gets us. Okay, so the cubed root, we're looking for cubed roots in these cases. The cubed root of x cubed is x. And the cubed root of 64, again, cubed root is 4. Be careful with that. So we have, it will be root minus root times root squared plus the product of the two roots plus the second root squared, 4 squared is 16, equals 0. Now we can take each factor and set it equal to 0. So here we have x minus 4 is equal to 0, which means we just found our first solution, x is equal to 4. Yay, one done. Okay, let's look at our second factor here. We have x squared plus 4x plus 16 is equal to 0. This is very rarely factorable, and in this case it is not factorable, right? The target product is 16, the target sum is 4. We're not going to come up with anything. So we will have to use the quadratic formula for this. And we can use the quadratic formula because this is a quadratic equation. I'm going to put it up here. We have x squared plus 4x plus 16 is equal to 0. Here we have a is equal to 1, b is equal to 4, and c is equal to 16. So we're going to plug this into the quadratic formula. That's x is equal to the inverse of b minus 4 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. It does look like we have some complex roots here. Let's see. So we get x is equal to negative 4 plus or minus the square root of 16 minus 64, all divided by 2. 16 minus 64 is equal to negative 48. So that gives us x is equal to negative 4 plus or minus, this would be the square root of negative 48. That is going to be complex, so an I will pop out. And then what's a perfect square that goes into 48? Well, there's 4, but can we do better? We can, because 16 goes into 48. So 48 is 16 times 3. The square root of 16 is 4, so we're going to have 4 times I times the square root of 3, which will be stuck under the radical, all divided by 2. And it does say to simplify, and all three terms here, the negative 4, the 4i root 3, and the 2 are all divisible by 2. So this would give us negative 2 plus or minus 2i radical 3. How many solutions did we end up with? We ended up with 3 unique complex solutions, and we're going to list them down here. We have x is equal to, we have 4, and then we have negative 2 minus 2i root 3, and we have negative 2 plus 2i root 3. So there's our 3 solutions. We have 1 real and 2 complex solutions. And one thing you may recall is that if we do have complex solutions, they always come in complex conjugate pairs, which they do, right? These first terms are the same, and then it's the same second terms, except the sign is different. In our next and last example, let's see what we have. 5m cubed minus 10m squared plus 10m is equal to 0. Okay, so one thing I noticed is that this again is a cubic function because this is a degree 3 polynomial. I am expecting 3 solutions. The next thing I noticed is that all 3 terms on the left have a common factor. So we do want to factor out this GCF. They're all divisible by 5m. So the first thing I'm going to do is factor out a 5m. That means I'm going to divide 5m into each term. That will leave behind m squared minus 2m plus 2 is equal to 0. Now we want to set each of these factors equal to 0. So first, if I set 5m equal to 0, if you need to, divide both sides by 5. If you already know, m has to equal 0, right? 5 times what equals 0? M has to be 0. We just found the first of our 3 solutions, 2 to go. Okay, now we're going to take this factor and set it equal to 0. That's m squared minus 2m plus 2 is equal to 0. Is this one factorable? Target product is 2, target sum is negative 2. It is not. So we're going to use the quadratic formula. If you like completing the square, you could also complete the square with this one pretty nicely. Not a bad one to try that with, but I'm going to use my quadratic formula. So I'm going to come up here and just rewrite it. M squared minus 2m plus 2 equals 0. A, in this case, is 1. B is negative 2. And C is positive 2. Let's plug these numbers in. The opposite of negative 2 is 2. So we're going to say, oops, sorry. I'm just going to go ahead and say m equals, opposite of negative 2 is 2, plus or minus the square root of negative 2 squared minus 4 times a times c, all divided by 2 times a. Now we have m is equal to 2 plus or minus the square root. This is minus 2 squared is 4, and minus 4 times 1 times 2 is 8. It looks like, again, we're going to be dealing with some complex roots here, because if we look under the radical, 4 minus 8 is negative 4. And what's the square root of negative 4? This one turns out nice. This is going to be 2i. So now what we have is we have m equals 2 plus or minus 2i divided by 2. We can simplify this. We end up with 1 plus or minus I. So how many solutions does this give us? This gives us 2 solutions, right? Because one of them is with the plus sign and one of them is with the minus sign. So our total final answer set here is going to be m equals, I'm going to list my real number first, and then 1 plus I and 1 minus I. There are my 3 solutions for this cubic function. These have been examples of solving higher degree polynomials by applying the quadratic formula. Thank you for stopping by.